Let's solve some Leetcode today. Leetcode mediums, equal row and column pairs. Given zero indexed x and integer matrix n by n integer matrix B. So this is square matrix. Returns the number of pairs such as row and column are equal. A row and column parts is considered equal if they contain the same element in the same order. Okay, so we have agreed. And we have there is one equal row 277, row 2, 0, 1, 2, or row 2, 0, 1, 2, 277, and column 1, which is 277. Okay. Yeah, so it's pretty simple. What I would do, I will join. Okay, so I would join, I will iterate rows, join into strings, use as key in hash in set, right? So what if we have the same and then as key in dictionary? Okay, dictionary, we will count it as a dictionary, and iterate rows join into string, use the keys in dictionary, add as key in dictionary, then iterate columns and check for the key. It should be set, right? Do we have to dictionary or set? I don't know yet. Let's figure it out as we go. Iterate columns and check if the key in dictionary or in set, and return matched column count. Right? Does it make sense? So we will go, we add 321, 127, 277 as a dict set. Then we go and we, by column, we 321, 277 is there, we increase return 1, right? The same here. We go 3211 and then 1445, 244. See, these there is the same. So, and their count as a different. We can use default dictionary. Yeah. So, okay, let's go. So for first we calculate rows and columns or len, which is let's call it L. Right? As the length of the grid, and then for for rows in a grid, we create also call it store as default dictionary of integer, right? Default dictionary, and then we, is it a dictionary? Is default dictionary of, okay, then we calculate key by join. So do we have like numbers? N could be from 1 to 200, and value could be 10,000. Okay, so we have to join by this, and we join R, then we store k plus equals 1. Okay, so we have amount of we finish this set step, right? Then go through columns. So we do a row in range L. Come on. Columns in range, right? And then here we calculate key by adding column to the and here I will define our result, which is 0. And we have agreed row and column. And then here, if OV result plus whatever we have in store under key, and we return our result. Anything weird in code? Here I have to join. Here I have to add plus. Okay, let's do this. Let's create pre-key as list, and here we pre-key append whatever we have. Oh, I shouldn't delete it. Pre-key is a list, and pre-key we append grid and list element, and then after that we calculate key by the same formula. It's important, just in case I missed something. And here we add whatever we have in as a result, and we have right. So for example, we have row 0, row column 0. Okay, let's see. Expected tester instance not found. Join our what? So I cannot join integer. All right. Let's try strx from x in R. This is first time I'm writing this thing. How is it called Python? They called something like not closure, but it should be probably 4x in R. No? What? Okay, this is a good thing. Pre-key we append str as well, because this is str. Yeah. So no. Answer is no. Okay, 3, 6. So why this is 3 exactly? I wonder. Okay. So let's print store. And store has given us 3, 2, 1, 1, 1, 7, 6, 1. 2771. Okay, beautiful. Then we here two print keys that we are finding. So 321176. So let's say finding. Oh, I'm still going by. I should be going by columns. Right, row column. So I start from 0, 0, 0, 0, then 0, 1, then 0, 2. I should start with and then go backwards. This is the weird part, yeah. Now it's working. I should rename row and column backwards, but yeah, doesn't matter. All right, 46%. Nice. Very nice. It's kind of simple, but 36%, I expected worse. Because come on, we are just comparing string. So string comparison is kind of expensive. And I believe it should be there is a better way somehow. And we about figure out how, right? Intersection. This is incredibly cool, but I don't understand what this is doing. But I will ask ChatGPT to explain this code to me later, probably, to figure out what this is. Can I ask it now? Okay. Please explain what this code is doing line by line. Oh, to make it hashable. Okay, so this is tuple. So it's adding tuple into hash. So okay, create a dictionary CNT where each key is a tuple. Okay, so hash an entire tuple. I don't know why it's faster. So this is the hashing. To track occurrences of grid in grid T, and yeah, it's pretty much the same, but they hashed entire row instead of me doing it in the string. They hash it into tuple, which is kind of the same. Oh, there is a counter. Nice. I like that too. So we created counter from tuple from every row, and then we added counter, whatever is counter. Yep, I like it better. It's more cleaner code than doing it with a string. But yeah, we did it. Let's go for the next one. Minimum to add to make parentheses valid. A parenthesis string is valid if only it's empty string. Can be written AD. Valid string parenthesis string. Can say parenthesis string. So can I do? I am just wondering. Can I do counter of string and then I can return counter minus counter between this minus counter between this as absolute value. No, it's not exactly, but I think it's not gonna work. Yeah. Because see, this is the problem. We have like closed open, and open counter is 0, but they're open in different direction, open in different yeah. No, it's not gonna work. So we do it old-fashioned way then. How about create stack? No, we don't. Do we have any limitations for using stack? No. And we create stack. We add we iterate through the string, right? If we see string, if we see open parentheses and stack -1 equal close parentheses. Open parentheses, yeah. Then we stack pop, else we calculate it. So if there is an open parenthesis, then we check if stack and stack is closed, we pop. Else we so we create count as a problem, and so we create stack, and we can say we create also problem counter, which is 0. So we add it as a problem. So we problem counter +1, right? Then we means that this is open parentheses. Then we stack, we append open parentheses, whatever we have, and we return problems plus stack size, because it could be more thing in stack. Right, so let's go and implement this pseudocode. We can write for C in string, problem count, Is there any problems? I don't see any problems. Let's run it and see. Error list cannot. List object has attribute append the typo here. List object has no attribute size. Of course, it's a length. Perfect. Beautiful. Old-fashioned always works. 100%. Chef's kiss. It's beauty. All right. Let's go. Let me copy the thing. Okay. I'm just 100%. What people do 100%. It's like balance, the same thing. Practically the same. Balance plus 1. Also, if char is equal for char in string, if char is equal open. Oh, it's interesting. So they calculate in balance if open. Yeah, I really like it. It's very nice. Very calculating. Balance of parentheses must prevail. So every closed parenthesis must have, every open parenthesis must have closed parentheses, and this is why. Okay, should we do one more? It's kind of like 20 minutes. Given an integer and return a list of all simplified fractions between 0 and 1 exclusive, such as the denominator is less than equal n. You can return the answer in any order. So we have n, you return 1 divided by 2. Explanation is unique fraction with a denominator less than equal 1. All right, so we have 3/4 here. So it sounds like we should have two enclosed cycles for E in range n, right? And then J in range n. And we can say if E divided by J if remainder from E divided by J not equals 0, we have like result thing, and we add result, we append some string with I divided by J, right? And we return result. So for example, this one, we have 4. We have 1, 1, right? 1 divided by 1, kind of 0. But we cannot use 0 here, so we have start from 1. And then n, because we have to use 4 plus 1. Okay, so we have 1, 1, not adding 1, 2 added, 1, 3 added, 1, 4 added, then 2, 1, 2, 1 will be added. It's not unique fraction because it's 2. Okay, let's see what what. Yeah, running it in my head is nice, but okay. So the problem is that should I add and so denominator should start from E. And the problem is that 3/4, 2/4, 2 divided by 4. Hmm. Okay, so how are we gonna exclude it? Because it's not unique. Should I create like store and like set and add set add I divided by j and if and I divided by j not in set. Kind of crazy. Store. So yeah, that works. Okay, let's see. 45%? It's not bad, right? Kind of bad for simplified fractions. How we can solve it faster? Maybe perform less comparison, or yeah, I don't know. Maybe somehow we can omit this storing thing into set, but yeah, looks good to me. And complexity will be it's squarish complexity anyway, but if we have 100, yeah, no problem at all. Yeah, let's see what people do differently. So GCD. Okay, this is I don't understand. For each and so we have GCD. What GCD global common identifier is equal 1. Oh, okay. So this is this is what I was doing with the stores. I'm doing with GCD, and GCD is also expensive call. So yeah, I probably like another good solution. Another good solution because, to be honest, my using store for that it's kind of like a hack, and to avoid repetitive fractions, but Yeah, this is more math way to approach this. All right. Yeah, that's probably it for today. Thank you for watching. See you tomorrow. Stay strong. Do Leetcode. Bye.